Hello, welcome to our workshop session, Networks, Clusters, Influencers, Introduction to Social Network Analysis with NodeXL. My name is Harald Meyer. I am the Chief Data Scientist at the Social Media Research Foundation. And our main project that we do is the social network analysis software NodeXL. And in this session, I will show you how to use the software, but also to understand networks in general, because networks are everywhere, and finding network data may be a challenge at some times. And I hope that this session will be helpful to you. You see my email address, harald@smr Foundation. And I would like to start with some organizational issues. We offer a free 2-month NodeXL Pro trial user license for all of you. And also, if you like to connect with one of our team members for a one-on-one session, that's also available. Feel free to ask any questions during the session. I'll be around to answer in the chat box. We'll also leave some time in the end for some further discussion. And the presentation you would see will we will also get as a PDF file. So the contents that I've chosen here is, I will start out with a couple of examples about networks, how they're used in investigative stories, and a couple of use cases, especially for NodeXL Pro network analyses. We'll then go to a theoretic part, so to explain to you some network basics. After that, I will turn to the key features of NodeXL. And then there is the practical part. First one is a tutorial how to conduct the social network analysis step by step. And that's a bit of a longer process, but we have a feature that's called automation. So right after that, I will explain to you how to automate NodeXL Pro so you can get to results very quickly. So here's an example that's from last year, a large investigation that took place in Finland. It was an investigation that took about 5 years, lots of data that was collected and processed. And you should really check out the link from this to this article. And it's a very nice way of storytelling using the network approach. This is not NodeXL. I'm not sure exactly what tool was used here, but it will give you some good understanding about storytelling with network data. But also, the story behind this is very interesting. So it was about money laundering, money coming in from Russia to Finland. And then the investigators, they looked at the money flows and involved companies and at the ownership structures. And they came up with a large network that was interesting to look at. Here is another example. So that's also from last year. That's from the German group, the Korrektiv. And they made a project about right-wing extremism on Instagram. And this is also quite a large project. They used some sort of a snowball principle. So they've looked at some Instagram accounts that were promoting right-wing content, fashion, for example, well, not exactly the extremist part of the right-wing, but obviously right-wing accounts and how they try to persuade users to click on their contents. And here you see that this is a network graph that was made with Gephi also. And this was also then constructed to another network visual that you see on the right. And this is just to give you an idea about large-scale network analysis. In this case, there's a lot of expertise is needed to get to the data and to analyze it, but it's not really necessary for a network investigation, the social network analysis, because here's an example that I've made 3 or 4 years ago This is a Twitter network map made with NodeXL. And I saw this network map and I thought, oh, what's going on in this group down here? And I noticed there are no profile pictures there. And I looked at them and noticed that these accounts were like 100 accounts. They were registered on Twitter within one or 2 days, and they had similar names with numbers. So there was definitely something there to look at. So I made a list of these users without a profile image, and then I downloaded tweets from them and looked at what they are exactly talking about. And this is a network map of these 80, 90 users. And to me, when I saw this, I thought, okay, this is not really a common thing. There must be some sort of fabrication behind this. And when we run NodeXL, we can also analyze the contents. So what has been shared, what URLs have been shared, what hashtags have been shared. And while looking at this, you see a lot of bogus websites that were in these tweets. And also they were using several hashtags around Trump, net gas, crude oil, but also some topics that really don't make much sense, but that's how spammers use tweets. They use trending hashtags and to promote their content. And it's very simple to turn this network graph to a smaller level, just to look at and how far do these users connect to each other. And from this perspective, I've noticed, no, they don't talk to each other. So it's not a network that connects the accounts of these users, but it's a coordinated approach to reach out into the Twitter sphere, to send out messages and just to connect with many accounts. And this analysis, I started and wanted to do some more of that, but after a week or so, these were all gone. I think maybe Twitter, the Twitter AI algorithms, they figured out there was something going on here. So I didn't have any chance to dig deeper into this. But this is a small investigation of the Twitter network, and I think it's interesting to look at, because it's quite easily done with automation, and it gives us some good insights from a visual perspective. There's always data behind this, contents to look at, but the initial thing for me was the network map that showed these images or not images of the users. Here's another example for a Twitter network map, and maybe you're familiar with the hashtag DDJ, well, I'm sure you are, and the GIJN compiles a list of top 10 DDJ links every week, and that's based on the data that we provide for the GIJN team. It's not so really about figuring out what's going on within these groups, but it's more about finding URLs that are of interest to the DDJ audience. And here you see the hashtags that have been used in just the past week. The Pandora papers showed up, and well, here are the links to the pages, and that will be then curated for the DDJ list every week. So you can summarize and explore any hashtag or any user, and that's one approach. Without digging deep into the data sets, you can just simply look at the contents. Oh, what has been interesting, and that's it. Another approach would be that if there's a trending article you're interested, you can search Twitter by the URL, and then you may get something like this. This was a special article in 2016 just right after the Trump election, and this person here was interviewed, and he was one of the inventors of the psychometrics that were used by Cambridge Analytica. And an article was widely shared. So from this perspective, it looks like a viral article, and we can see that with some practice that from the network shapes around here. Another way to use this approach is what you can measure the output of your newspaper, news outlet. You can choose different approaches with your query. These are two examples from the New York Times. So on the left side, you see a search about tweets that talk to the New York Times. So it's at New York Times. That's what we get here. But we can also look at the URLs that have been shared from the New York Times. So not from the account, the main account itself. So when people are sharing stories that they are interested in, they put in a URL, and then we get a different view on the data. So you see the different discussions about different articles on the right side. And you've noticed already that these network shapes are different. They come out different ways. You never really know what you get until you see it. And a couple of years we did a Pew report, and we figured out that there are 6 basic shapes of these networks. So there are polarized crowds on the top left you see here. That's polarized topics, political topics. And opposing to that, there are tight crowds. So that's what we will get, we will see from the hashtag GIJC19. So when experts come together, talk to each other, they are tight, and it's a dense network. There are also brand clusters. So that's like the unconnected large group that you see right here. And it's not really, it must be a brand, but it's a metaphor saying that a lot of people talk about the topic, but they don't connect much, or they don't get retweeted. But this is a certain shape within these network maps. And opposing to that, if it's not connected, it's community clusters. And it's also community clusters up here in the polarized and tight crowds. But in this case, it's opposing to the brand clusters. And also, third, or five and six, are the star-shaped wagon wheel clusters, these groups that have structure from in-app and spokes structure. That means there's popular content. I send out a tweet, I get 1,000 retweets, and I get this star shape pointing at me. But also there are some support networks. If something's wrong with your Netflix stream and you say, hey, what's going on Netflix? You will get some answer from the service account asking what's going on. But it's not only these support networks with the out hub and spoke structure. It is also retweet bots or spammers who just connect to many other users who retweet a lot. And that's similar also in the shape. This is what it looks like from a bit different perspective. And well, if you're interested in more information on that, there's a report. It's 30, 40 pages. And also we have a nice video that's of just 15 minutes where the director of our research foundation explains these network shapes. Okay, now let's take a little step back at a look at network basics. So in general, a network is a collection of connections, and that just means it's a long list of a long list, or maybe it's 2 columns from one person or entity to another one, and that's what we call an edge. That's a connection. It's some sort of relationship. If you like something or retweet or mention somebody, then a connection is made from one user to another, if we speak in a social media network way. And you see here, well, the dots is what we call a vertex. That's our vocabulary. Other people say it's a node. We can also say it's an entity. This could be a person, a user, or a company. And then we have clusters. And a cluster is a group of vertices or a group of users. Tweaking behavior, or well, it could be anything really. And we have to distinguish between different types of networks. So there's the undirected network, which is maybe your Facebook friend network. You connect to each other. That goes both directions, and you don't have an arrow. It's different in a directed network. For example, you follow someone on Twitter. Then a connection is made between you or from you to the other user. And maybe it comes back, then you have arrows in both directions. Also, we could speak of weighted networks. So the arrow between two vertices may become thicker, which means there is a stronger connection between two of these entities. And also we can distinguish between single mode and multimodal networks. Twitter network that I've just shown you is from user to user, so that's single mode. But also you can construct networks differently. So let's say a company donates money to a party, and also donates money to organizations or funds organizations, and then we can look at how much money is flowing. There's several donations, and you can sum them up, and then the weight between these two entities grows. So that's also a way to look at networks. There are a lot of network tools out there. So besides NodeXL, there's Gephi, which is a very powerful free tool to use. And well, there's SocioViz, Netlytic. You probably aware of Neo4j. Linkurious was involved in the latest releases of leaked data. So, well, it's all network tools. They do pretty much the same. Some look more pretty, others don't. Some allow very large data collections to be analyzed, others not so big. And there are file types that you can use. So in general, you can find network structures in any table, an Excel table, CSV table, like if you see here on the right. So there's a source and maybe a target. So this is an example from The Simpsons. So Lenny and Carl are friends, Carl and Barney are friends, or Homer and Marge are married. So that's just what you need to build a network. But it's always nice to have additional data. So it's not just these two users or two entities. Sometimes we get additional data, and that's the metadata. We get a time, a place, with content. So there are lots of ways, and I would show you that with the Twitter data, what kind of metadata we get about the connections, the edges, and also metadata about the users that are involved, and that are two different levels. You can also find network files. So there are GIJCs files, GDF files, GraphML, UCINet, PAGIC. These are files that already have network formats with a list of edges, network edges, and also vertices. The question is always, where do you get the data? For example, Twitter, YouTube, Wikipedia, they all have APIs. We can access them and construct networks from them. There's just recently seen CrowdTangle network made from a list of groups that were posting about COVID, pro and anti vaxxers, and then network was created between group and the URLs or domains posted in a group. And when you get hundreds or thousands or many thousands of these connections, then you will find clusters of groups and who post similar contents. You may find network data in databases, in documents that you might also have to manually extract. It's always nice to have some sort of machine that does it for you, but sometimes it's just good enough to use your manual input. Use your hands and type in from and to. I know that may be painful. It depends on how large the network is, but it's also a good approach. So this is what NodeXL looks like. It's an Excel plugin, and up here you see the NodeXL ribbon with all the commands that can be used to analyze a network data set. And it's very simple to get from an empty workbook to a populated workbook that has the full social network analysis of certain data. In this case, it's the search query GIJN or GIJC21, and I just did this this afternoon. And you see what people are talking about the network and the conference, and this will look very much different by the time the conference has started, when some of you or many of you start tweeting. And there will then be much higher volume. There will be different clusters to see. And yeah, I will post an updated network graph in the chat when we have this session. There's some system requirements. So this only runs on Windows operating system, and you need Microsoft Office, Excel. A 64-bit system is very important for if you want to have larger networks analyzed. And well, that means the more RAM you have on your machine, the better it is. And well, based on the machine's hardware, then you can say that there's like a maximum of maybe 50,000 tweets that you can analyze at one time, around 100,000 edges, or 20,000 or maybe 40,000 vertices. But it depends on the machine and the underlying data structure. But that's something to keep in mind. We get small to medium size network images, the really large ones with hundreds of thousands of tweets or millions of tweets. That's where you need to go to GIJC, for example. And here's an overview of the key features of NodeXL. We have data importers directly from Twitter, Wikipedia, YouTube, also Flickr. And then there is the network analysis part. And there are calculations about the network metrics, which means the overall network calculations. So how large is the network? How dense is it? But also there's a cluster algorithm in place that finds structures within this large network structure. And we then can calculate metrics about these clusters or groups. And on the third level, we have vertex metrics. So these are calculations about the users or the entities in the network. And there are a couple of calculations about these metrics that I will show you in just a minute. The third part is content analysis. So, and then that's the really very powerful part of NodeXL, because when the cluster algorithm has found groups, we'll then analyze in how far not in how far, we'll analyze the contents that have been shared within these groups. So that's on the one hand, the text analysis, so which words were most frequently used, which word pairs. The top contents analysis is which hashtags have been used, which URLs, which domains that have been derived from the URLs. Along with that text analysis, we also have a sentiment analysis running. So a predefined list of words, positive and negative, and that will count. And then we see, oh, is this mostly more positive or in a negative discussion? And another part of the content analysis, type series analysis. So when was tweeted, when are the peak times? the discussion. And when that is done, we get to the visualization, to the network graph, the network map, and that's what you'll see here. And if you like, you can then share your data sets within our NodeXL Graph Gallery. That's a public website where our users can share their data sets with the world. And the main feature you see down here, that's automation. So you don't need to exactly know how all of these steps technically work. Or you need to know, or you should know that there's a short path to it. We have data recipes that have a list of tasks that are running. And when we start importing data, we just click and wait. It depends on how large the network is, but maybe after 20 minutes, 30 or an hour, or maybe even longer, the whole network is done and you don't have to put your hands on anything when these data recipes are working. So here's now a different look on these features. So the network overview means we get information about the whole network, how many users are there. Group analysis means you see these boxes. Each of these boxes are groups that have been found by the cluster algorithm. And then we have vertex metrics for each of these users you see here. And you see some are larger, some are smaller. And we then use these metrics, for example, in degree or betweenness, that tell us some sort of popularity of the user. We're just looking at this network map. So we see usually in the middle large account and around in the periphery smaller accounts that are not that important. The content analysis part is seen also in these texts at the top of each of these boxes. So in this case, these are the top used words in a cluster. And this is an example from the output from the Sun newspaper. And well, here is some talk we see about Queen and Prince Andrew and Jeffrey Epstein, for example. Down here, this is a cluster that talks about sports, Manchester United transfers, or Cristiano Ronaldo, Sancho. So that gives us a good idea what's going on in these clusters just by simply looking at these top 10 words. Or we can make this the top 10 hashtags used. That's up to you. And you also need to know that there are several layout algorithms in place. So in this case, we have the group in a box layout, which shows the largest group that has been found in the top left corner, and the smallest group in the lower right. And that's usually then 1 or 2 users connecting down here in this area. They are not that connected. And so this is really the rather important part to the left. And also there's another algorithm in place that exactly makes these structures. And this is what we call the Harel Coren fast multiscale layout, which is very helpful for understanding these networks. Now, the question is always, who is influential? And here is a fabricated network map to prove some points about influence. And if you take a guess, who's most important here? And you say, oh, could be, is it F, L, or Q, or is it Z? Well, it's hard to say. It depends on the perspective. So if we look at the network vertex metric degree, which just means the connections in the direct neighborhood, the adjacent users to one user. And in this case, this is the letter Z down here that has the highest value. It's degree of 6. It means there are 1, 2, 3, 4, 5, 6 users directly connected to that. And this is a measure of popularity. From an undirected perspective, this can also be split in degree and out degree. And then when we have the high in degree, you're popular. We have the high out degree, you're probably a spammer. And one very important measure is betweenness centrality. And this works as a calculations for the distance from one user to all the other users in the network. And it counts how far do I have to go well, from one user to all the others. And then this is written down, calculated. And then you will find some users, or in this case, here we have the letter F, that's right here, that has the highest bridging function. Betweenness means some high betweenness means you have the ability to reach across groups. And that means if we would remove letter F right here, then this network would fall apart into different pieces. So then we would have another component here and the other one down here, and the network gets smaller. Closeness centrality shows us in how far in the middle is a user or an entity. And here you see LP, F, and Q. So these are most central or most close vertices in here, and it's a bit different than what we've seen here before. And the third one that I would like to point is eigenvector centrality, which means that if you are connected within a group, so you have your connections and your connections are also connected to each other, then that shows us that there's some sort of community in here. And combining different metrics and mostly between centrality, degree eigenvector centrality helps to figure out the position and the influence of a user in a network. In NodeXL, we have 3 cluster algorithms. They all work pretty much the same, but they give a bit of different output. So Closet Newman-Moore, you see on the top left, that's the most popular we have. And I like to term this as the network magic. But it's not magic, it's mathematics, and there's a list of 7 or 8 equations. There's just one down here. It's quite complicated calculations, but it gives us very, very good results. So don't need to understand the equations. Think of it as network magic. This is the time series analysis. We get a spreadsheet that looks like this. We have that in a practical part in just a bit. This is a look at content analysis from a text perspective. So yeah, text and sentiment, that goes together. We have this box where we tell which column should be analyzed, where is the text. So the tweet text, we pointed to that. And then we have a list of words right here that are not important at all and that we want to remove from the data because it just won't help us with these skip words or with these stop words. And we have a predefined list of positive words and negative words. In this case, English. We also have some other languages. So we have German, Korean. We were working on Spanish as well. I can always need some help with that. Lots of languages that we would like to cover, but it takes a while to get to good, solid lists that are really helpful. And you can also customize these lists. You don't need to go with positive or negative. You can create your own list of keywords. So what would be words? Maybe left-wing political discussion, right-wing political discussion. So or anything you can think of, you can just put it in there, and then NodeXL will count how many of these words are actually used in the data set. This is the spreadsheet network top items. So that's where we see, we can take a look what's actually going on in these groups. So we have on the left the overall count of words. Let's say here's top words, top hashtags, domains, and URLs. But also then the cluster algorithm has found these groups, and then we look, okay, what is the top URL in group 1, in group 2, in group 3? What is the top hashtag in group 1 or group 2? And with this kind of information, you can much easier figure out what is going on in such a group, in such a cluster. We have the feature autofill columns. That's very helpful to color edges and vertices, and also tell what we want to show from the content analysis. Do we want to show top words, word pairs, hashtags? That's what you set with this feature autofill column. So doing this by hand copy and pasting, that's very painful. This feature does it all for you. There are different layout options. So I've mentioned group in a box layout and the entire graph layout. It does look pretty different if we just lay out everything in one large network map. That's what you see here on the left. And the same data set looks like this when using the group in a box layout. But sometimes it's good to look at both sides. Usually as a standard, we look at the group in a box layout because we have the content analysis directly involved, which helps us to very quickly understand or get an idea of what's going on in these clusters. So besides the tree map layout that you see here on the left, there's also the force-directed layout. We can move these groups a bit around, so from a force-directed perspective. And while you think here, oh, there's lots of cross connections everywhere, when we look at this network representation of the same data set, we see it's very much divided. In this case, it's because it's a clash of hashtags, the same hashtag that was used by two very total different populations. This way may be another way to look at the users by laying out on a scatter plot an X and Y axis, and then we use eigenvector and betweenness centrality, and up in the upper right corner, you see the very, very important users who have both high betweenness and high eigenvector, which means they are well connected within a group and also have the ability to connect to other groups. While on the lower left, we have low eigenvector, low betweenness, and these are not that important. This example is from the German Bundestag, the politicians that were tweeting in the past election period. This is the NodeXL Graph Gallery. That's where we can export our data sets to share it with the world. And then you can click on any network report there, and then you get a whole page, and it pretty much shows all the information that you have in the workbook, but it's presented in an easier, simpler way. So you should really also check that out. And last year we have a new product which helps us a lot to better understand these network data sets, so which makes it much quicker and easier to get to the essence of a group. And this is based on Microsoft Power BI. And it just pulls in the workbook and constructs a nice dashboards, many different topics. And in the end, I will show you a short overview of that as well. Like I mentioned, the key feature is automation. There are so many options, and it may look a bit complicated in this case, but we have these data recipes in place. And when you go to our website here, you'll see different data recipes for different platforms, because the different platforms have different column names, and that's customized for these. And even though for and also for Twitter, we have different recipes for smaller networks or large or very large networks that do all the same, but we want to get to a network visualization where you can really see something by looking at it. So if it's messy and you don't know how it's set up, then it's hard to figure out what's going on. This is just one slide to show you a YouTube discussion network. So you can also look at a network perspective on a YouTube discussion about one video. So that's what we see on the left here. and it's constructed by, with comments and replies. So somebody comments to a video, and there's then a connection between the commenter and the publisher of the video, and then people reply to a comment, and then we have another network connection that's made. And this looks similar to the Twitter networks that you've seen before, but the overall structure is different, and it's a bit harder to figure out what's going on in these groups. We can also pull in like 50, 100 latest videos on a certain topic, and then the top 100 comments and replies, and then we see what has been going on YouTube the past couple of days or weeks. Also, we have video network representation here. So the vertices are videos, and the connections are based on the recommendation algorithm. That's something that you can play around with. It's more for a research project. How does YouTube recommend videos? How does it change over time? That's interesting to look at. So you might also want to check this out. This is also possible to download data for Wikipedia networks. So in this case, on the left, you see a vertex is here a page, and connections are made between the hyperlinks within the text. So you are directed to different pages from one article, and in this case, then you see this is the article social network analysis, and then there are semantic clusters that you can see. But you can also download comments from the discussion of these, from the discussion around the creation of these articles. And were some bots also involved in here, and users with just IPs. But you can also get an idea what the discussions are about. This is more of an advanced topic, and it takes a little more practice, and the networks don't get that large, but it may be a good pointer when you investigate a Wikipedia article that's been changing a lot back and forth. So this could be one solution to get a grip on what's going on. All right, Twitter networks now. We have 3 different data importers. Most of what you've seen so far is the Twitter search network importer, where we get 18,000 tweets per search. That's the limitation by the Twitter API. You don't get data that's older than 8 or 9 days from the date of query. And it might be reduced data volumes for trending topics. So you might just only get 95%. But then the time frame for 18,000 tweets may become short. So to look for a Super Bowl, during the Super Bowl, you just get 1 minute maybe. And then we have the Twitter users network importer, which helps us to dig deep into certain users. So during your Twitter search network analysis, you may find a couple of users that are interesting. So make a list of their account names and then put them in the importer, download up to 3,200 tweets by them. And then you can see what are these users talking about, how do they connect to each other. And we have a third importer. So if you get to any kind of tweet ID list, then you can also put these IDs into the importer, and it will then hydrate the data set. And this has really no time limit at all. There's some tools out there where you can get large amounts of Twitter data, and with this one here, you can convert this into a network. All right, then it's time to get some practical. So the relationships that we have in Twitter networks are, we have the just tweet, which means no connection is made. This is what we call the self loop. If a user is mentioned in a tweet, then we have the relationship mentioned. If somebody replies to another user, that's a reply, and obviously there are retweets. And well, if a tweet gets retweeted where another user is mentioned, then that's mentions and retweet. Also can get follow edges, but I recommend to not mix these. These will give you a whole different structure, and it makes sense to look at followers on for some users, but for these approaches, I recommend to not do that. Okay, then let's have a look at the practical side here. So the query design is very important because you can rule out some things, you can filter with different dev techniques. So here are 2 links to the official Twitter developer search operators where you can check out what's possible. And a very helpful guide in a blog is also found here in this link. And you can build advanced queries with parentheses. Lots of things are possible here. And here's an example. If you just look for the search word Tesla, you get 18,000 tweets, maybe 10 hours time frame. If you put an @ before Tesla, then you only get tweets that are directed at Tesla or written or sent by Tesla. And if you use the hashtag Tesla, then you only get tweets that are posted under this hashtag. Going back to just Tesla, test only on the left here. Only Tesla will include @Tesla and hashtag Tesla. So that may be important. Then here's the step-by-step analysis. And now I will show you how this social network analysis works. So we have the empty spreadsheet here, we have the importer, and actually I will import the data recipe right here, and let's say integrate export files, and I now import Twitter search, and I say GIJN or GIJC 21. And now I click OK. This is now data collection process. It gets 100 tweets per page right here. And while this runs, I have already prepared the data set. So this is what you get when the process is done. It's the raw data. This is not, the recipe is not running right now. Just to show you what is going on in these steps with a social network analysis process that is going on in the data recipe, and this is now step by step. So we have the edges data. So this is how users connect, and when we slide to the right, so it's like this. So relationship. This is when was this tweet sent. Well, let's go back once more. So what's the relationship? So this user retweeted GIJN, and also Maria Ressa was mentioned in that tweet. So, so this is obviously about the Nobel Prize. Here in this column, you see the text of the tweet. And also then there are URLs, hashtags within these tweets that are extracted. And if we go further to the right, then its timing is split at what date and what time. You can click on right here to get to the tweet. Some of the users show their locations, get that long data, but usually in this case, no. It's not very common anymore. It used to be more popular. We have the tweet ID, and just go further to the right, we can then see our favorite count. So let's sort by favorite count, and then you get to the most favorited tweets in this data set. The Twitter AI does define the language. So E is English, Spanish, U and D is undefined. Maybe it was just an image shown, or not possible to detect the language. Further to the right, we have the retweet count. And well, this is all metadata about the connection. And we have now the second spreadsheet that was populated, and that is the vertices spreadsheet. And we also get metadata about these users who are involved in a discussion. And well, there is the name, or actually the vertex name is the account handle. And then there's the name also associated with that. You get the statistics of how many accounts are followed, how many followers there are, how many tweets have been sent, how many favorites have been sent. Also, the self-description is here. The location, and it's a self-location any user can set. Web link within the description, the date when Twitter was joined. And yeah, there's some more interesting columns here. So list count, how many times was that user listed? And so on the top we have New York Times. So this is all information that might be helpful. And then custom item menu action, we can click on that, we get to the Twitter profile. Okay, to analyze now, we prepare the data and then we count and merge duplicate edges. Actually, we don't want to merge, we just want to count, and that adds one column all the way to the right. And that means it's the edge weight, and we sort also from largest to smallest, and we see, so this user, I've looked at this before, it's some sort of spam, angry person, maybe some sort of issues, but there are 59 connections made in this data set between this user and Sapa News. That means edge weight of 59 means there were 59 different tweets where the user was mentioned or retweeted. And that helps us also then to visualize the data later on. Now we have this, and we go to groups, and there's group by cluster, and that's what we want to do now. We want to run the cluster analysis. It's preset closet in one more. We make a check mark right here, and we click OK. And that just takes a couple of seconds, and then you see this group's spreadsheet was empty before. It has now been populated. And in this data set, we found 36 groups. And currently, we don't have anything else in here yet. Well, by the way, I've not mentioned that there's the link in the presentation to this tutorial that you can download as a PDF file. So this is about data import, prepare data group by cluster. That's what we just did. And now we calculate the metrics. There is up here the section graph metrics. Click on that. And then we select the first 10 or so up to here. We can add also group metrics. And say calculate. And depending on the size of the network, that may take a couple of minutes, but in this case, it's pretty quick because it was just, I think, 1,000 tweets that I've pulled in. And now we have new columns on the edges spreadsheet. So vertex 1 user is in group 4, vertex 2 user is also in group 4. We can scroll down or filter. Also, well, this is shown on a vertices spreadsheet. Go all the way to the right. You see which group number has been assigned here. And also now we can see the metrics right here. So the in degree, out degree, betweenness, closeness, that has all been calculated in the last step. We can sort by betweenness centrality. Let's do that. And but it's no wonder a GIJN is the top influencer from betweenness centrality. But also see there's a high in degree, highest in degree around here. And we see the out degree of 57, which means there's a lot of good activity with the Twitter sphere. So it goes both directions. Some users, they rarely tweet and only get in degree, don't mention anybody else. And well, this is a reflection of a Twitter account that is networking. So these are the metrics that have been calculated on a vertex level. A couple of more there. And also now we see here on the group spreadsheet, now the groups metrics. So we see that in group 1, there are 295 users, how many unique edges there are. These are the some network metrics that are interesting to look at. Well, sometimes it's interesting, sometimes it's not. Sometimes you just want to look at the map, or you just want to look at the top overall shared contents. It depends on where you're going with this. Okay, then the next step after the calculation of metrics, then is time series analysis and text analysis. So we also do that for graph metrics. We'll deselect the other ones here, now let's say time series. And we find the column where the date data is, and that's relationship date UTC. Click OK. We want to show it by, let's say by days or by hours. Let's say by hours, and we calculate that. And here you see then it's been just, well, we get 3 or 4 days of data and see some peak times right here. So it just has been picking up a bit of speed yesterday and today. Not that much going on in the days before that. Okay, we now deselect this one and we select words and word pairs. And this is what you have seen before. In the presentation, we select tweet, the tweet column, and now we run this feature, and text analysis usually does take a little longer than the other steps. Give it a couple of seconds here. Should not take very long. So that's the waiting time that you will not have when you have the recipe running. And when you set up the importer, click OK, get your coffee, wait, and then at some point you see the network analysis, the content analysis, and the visualization. But this is taking a little while. I've already prepared this before. Wait for another couple of seconds. Here it is. So there are now new spreadsheets that have been created. One is words and words. One is words right here. So what are the top words here? And obviously we have not skipped some of these words from different languages. But that's the count of words, and how many words were on the sentiment list 1, that's positive, list 2, that's negative. And well, same thing we have also on the word pairs spreadsheet. And well, here you see then for the words right here with the count. And well, that's the text analysis part. Okay, then next is autofill columns. We want to get to a visual with Harold Corin fast multi-scale layout. Let's set that, and we use autofill columns. And I think we'll have to check how much time there is left. So I will now switch to the recipe. I will pull in the recipe. So that makes it a bit quicker. So this is let's use this one. And now when we click on all of the columns, you see that there are some presets here. So we want to have vertex size by in degree. And well, here's the size from smallest will have a size of 50, largest to a maximum of 1000. You ignore outliers. I want to give the vertices a label, but not all of them, because then it might get messy. And well, here on the edges spreadsheet, we want to visualize the edge rates, the strength of the connections by using the color, the width of the of the connection of the arrow between the users. We can use a different style. It's a solid line, it's a dashed line, dash dot, that's also possible. And when there are lots of connections or edges going across on top of each other, then want to use some opacity as well. And now I click on autofill, and that's also another step that takes maybe 1 or 2 minutes. And now I can just jump to the end result, and that's what you see here. So when these calculations are done, we show the graph, and this is the network graph of GIJN or GIJC 21. And that's the full analysis. And now I can also, let's see, the automation recipe is also still running. I was hoping that this would be done in time. Oh, that's something. I clicked this away, sorry. Go to the NodeXL graph gallery. And when the recipe is finished, then the data set will show up here. So here's the one that I've previously made. There's the network map. We can scroll down, see a description, and overall network graph metrics. And when we scroll down, we see the top influencers that have been identified by between centrality. Here you see the top URLs by the entire graph, by group, and then you can use this also to analyze your data set. All right, let's see how the timing is going. Just a couple of minutes left. And yeah, I would like to point you now to our NodeXL Pro Insights. And this is what you see here. So this is a web report. It can be kept private, but this is the one I made publicly available. This is what I sent to the GIJN team every week. So they get a network analysis of the search term data viz with a Z or data viz. This will collect some more American English, British English combined tweets. There's this operator that will just give us data from exactly the past week, from Monday to Sunday. And well, this is the other report. That's hashtag DDJ or data journalism, also the whole week. We had started out with just hashtag DDJ, but over the past 1 or 2 years, the traffic has been going down. So we expanded the query and we added data journalism. That means if in any tweet there's the word data and journalism, then it will also pull in these tweets for analysis. And we have this report now with a lot of dashboards, report pages. This is the starting page, and we get some good overview now right here on the overview page. So here's the list of the groups, and if we only want to know what's been going on in group 1, we can click on that. My connection maybe a bit slow. So now we see all filtered down, only hashtags here that have been mentioned are used in group 1. Here are the top domains. And also this is the connections table. So how did these users connect to each other? And we have, can look down here at the bottom with more tables. So that means the top active users in group 1 is this one here without a profile image. We get a tooltip and we see, okay, this has been active since 2015, 139,000 tweets overall, just a couple of tweets by the user in here. So that's the most active users. And we can look at the most mentioned users. That would be then The Economist in group 1. So this is most popular one. We can unselect right here. and see, well, you just click on, let's say, well, this user Fusion base, let's see. And now we see on the left side all the active users. So we can scroll down. These are all users that have been connecting to this certain user. Yeah, so I would just point you to 2 or 3 other report pages right here. What's very interesting is yeah, the time grid analysis. So that's also very helpful for yeah, for investigating data when you might be looking for bots. Then you might see that in every first minute of an hour, and then maybe first second, there are more tweets than in the other minutes or seconds. And this may be helpful for some cases. We can also look at the time grids based on the dates when the users in this network joined Twitter. So look at by year and month, and well, many from 2009 in here. Well, we have lots of options to look at the data from different perspectives, and one very interesting one is also the location map. So the user self-description, where they are located, that also may help. So let's see, that's what's going on in group 5. Where do they come from? So that's mostly, that's pretty global, mostly Europe. Group 2, let's see, yeah, that's a very European based group. And that's how you can explore now the data. It's also in the workbook, but with this NodeXL Pro Insights, it's much more easy to figure out certain aspects. It depends on your objective, where you're going, what you would like to understand. And this here offers a lot of opportunities. Okay, this is my presentation. Thank you for coming out. I will be in the live session answering your questions during the video, and also we now have some minutes, maybe 5 or 10 minutes to further discuss your questions. So thank you very much for coming out, and yeah, please ask me your questions now.